Hello everyone, and welcome to another video in my channel. In this video, we are to prove that the number, that is cube root 2 plus root 5 plus cube root 2 minus root 5, is a rational number. What do we mean by rational numbers? That is numbers that can be expressed as fractions. We can have a whole number such as 3. We can express it as a fraction by putting over 1 here. Now, all the fractions are also members of the set of rational numbers. For example, 1 over 3 is a rational number. Then 1 whole number, 1 over 3, for example, is another rational number, because this is a mixed fraction and this is an improper fraction, while this is a proper fraction. So all fractions are members of the set of rational numbers. Apart from that, we can also include decimals, numbers that can be written in form of decimals as rational numbers, such as 2.13. Very good. So we have 2 decimal places here, and because it terminates at the second decimal place, this is a rational number. I can also include numbers like 2.1345 as members of the set of rational numbers, because the decimal part is repeating. So members of the set of rational numbers include the whole numbers, proper fractions, improper fractions, mixed fractions, or decimal numbers whose decimal part can terminate, and then decimal numbers whose decimal part repeats. These are members of the set of rational numbers. But numbers like root 2, cube root of 4, the fourth root of 2, etc., are members of the set of irrational numbers. Other members of the set of irrational numbers are our e, then pi is an example. They are all members of the set of irrational numbers. So the number we are given, which is the cube root of 2 plus root 2 plus the cube root of 2 minus root 5, are members of the set of irrational numbers. So when we add these two, we are supposed to get a rational number. So this question is saying that we should show that when we add these two, we will get a rational number. How do we go about it? That is what this video is about. I am going to first of all let x equals to the number, that is the cube root of 2 plus root 5 plus the cube root of 2 minus root 5. Good. So basically, I am writing the number in this form: x equals to a plus b, where a is the cube root of 2 plus root 5 and b is the cube root of 2 minus root 5. Good. I can cube both sides of x equals to a plus b. I can cube here and then cube this side. So if I expand this, I have a cube plus b cube plus 3ab times a plus b. Very good. Now let's remember that a is this. So if I cube this side, I'm cubing this side. This and this will cancel out, giving us 2 plus root 5. Also, if I cube this side, this and this will cancel out, giving us 2 minus root 5. So let me write this one in place of a cube plus b cube. It becomes x cube is equal to 2 plus root 5, then plus 2 minus root 5. Now, this is times 3ab, that is 3 times the cube root of a, that is 2 rather, plus root 5 in brackets, and 2 minus root 5 in another bracket. And let's remember that a plus b is x, so I'll put x here. Now let us simplify. This and this, sorry, not this, this and this will cancel out, so x cubed is equal to 2 plus 2 is 4. Now if we open this bracket, we are going to get plus 3, the cube root of 2 times 2 is 4, then root 5 times minus root 5 will give us minus 5. Then let's remember there is an x multiplying it. So x cubed is equal to 4 plus 4 minus 5 is minus 1, and the cube root of minus 1 is minus 1. So I have minus 3x. So it becomes x cubed plus 3x minus 4 is equal to 0. Great. So I have this. I now need to find the solution to this cubic equation. And x equals to 1 is a solution, because when we put 1 where we have x, I have 1 cube plus 3 times 1 minus 4 is equal to 0. 1 cube is 1, 3 times 1 is 3, minus 4 is equal to 0. So we have 0 is equal to 0. Therefore, x minus 1 is a factor of this polynomial, which is x cubed plus 3x minus 4 is equal to 0. Now, let us find the other factor of this polynomial and see if we can find the solutions of that factor of this polynomial. We can do that by dividing this polynomial, which is x cubed plus 3x. Now, because there is a term missing, that term is a term with x squared rather. So I'll put a box here, then plus 3x, then minus 4. Now our factor is x minus 1, because when we say x minus 1 equals to 0, we have x equals to 1 there. So let's divide this polynomial by this. X cubed divided by x will give us x squared. X squared times x will give us x cubed. Now x squared rather, times minus 1 is minus x. If we subtract it, we are going to get x, then plus 3x. Please, this is squared because we are multiplying this by this, and this is squared also. Now, x squared divided by x will give us x plus x. X times x is x squared. X times minus 1 is minus x. Let's subtract. This and this will cancel out. This times this is plus. So 3 plus x is 4x. We will bring down this minus 4 and then do the division again. 4x divided by x will give us 4. So plus 4 here. 4 times x is 4x. Then 4 times minus 1 is minus 4. So the remainder is 0. It now means that x squared plus x plus 4 is a factor of this polynomial. Great. However, x squared plus x plus 4 does not have a root or roots that are whole numbers, because if we check the discriminant, which is b squared minus 4ac, we will see that b is 1, that is 1 squared, minus 4 times a is 1, and c is 4. So we have 1 squared minus 16, which is minus 15. If we put it inside a square root, we have minus 15, which is a complex number. So this does not have a solution point that is either a rational number or a whole number. Therefore, since x is equal to the cube root of 2 plus root 5 plus the cube root of 2 minus root 5, and we have it as equal to 1, it then means that this is a rational number. Thanks for watching. See you in another video.